are proportional controls with two light sensors. So if I were trying proportional steering before we test, good. So it's done. Let's download. Okay. Something definitely not right. So we have good. So anytime your robot misbehaves, the rule is that machines don't make mistakes. It is humans who make the mistakes. So you said you are thinking here, right? When you make a decision, what happens? If I see a value greater than 50, the decision is not given to anybody. So these controls are not having effect. What do? You say this depends on what? A logic. And then the result from this is what is driving that what? That logic. Are you following? Otherwise, your logic is not driving anything. The same thing applies here. The switch block depends on what? A logic, and then it is driven by what? The comparison of the light sensor values. I think it's done. So we have okay. That is a small error that is happening there. So what that means is that let me just demonstrate that before. So what you can see is this. You see, when I see, I think I want to demonstrate this in front of. So when this one, when the light sensor sees the black, I'm expecting it to do what? To turn in which direction? It should have been turned this way, but rather what's happening? When you see the black, it's turning in the wrong direction. What does it mean? It means when I was supposed to stop motor A and move D, I'm stopping D and moving A. I follow it. And the reverse. What I can do is to either change it to the program or just swap the two sensors and say, okay, the two motors, I have misconfigured you. I've given this control to D and this control to A. I follow it. So by just doing that, and I have my robot behaving right. Are we there? Good. So when you have that error, you should know where it's coming from. So that is what you have. We'll do light sensors. But of course, you can see the speed will need more control. I follow. With that speed, you need more control. Here, it's just like having the Drankin Sailor thing, but just that this time, it's a little control because of the two light sensors. So what you can do is to say that I can have a multi-state with two light sensors, like we did for 5, which means for each of the switch blocks you have 5 different. So remember, the outside one will have 5, and for each of the outside one, the inside one will have 5. So 5 by 5 by 5. That's a lot of control you can have for these two light sensors. I follow it. I'm not going to get myself into that mess right now. I only want you to know the possibilities. Now, we want to look at what we did for proportional steering. Proportional steering with two light sensors. With one light sensor, the idea was to put the sensor or the robot half on the black, half on the white. But with two light sensors, the mindset is to grab the robot in between what? To grab the black line in between the two sensors of the robot. So what is our target? The target value is that both sensors should be seeing what? 100. Are we there? That is our target. That both sensors should be seeing 100, so we can keep going what? Keep going straight. The only time we want to stop going straight and 10 is when one of them is not seeing that one, that 100. So we write a simple equation to say that the steering that should apply if I were moving at a constant speed of 40, the only time I would need steering is when some error has happened. If I have light sensor on 1, light sensor on 4, and I say subtract, and the result should go to steering, what is going to happen? If I have this one recorded 100, that means on white, and this one recorded 100, also on white, what is going to happen? Steering will be what? 0. Constant speed, I move forward, I follow it. If I have this on white and this on black, what will be the steering? 100. Total 10 to what? To my right. If I have this one rather on black, 0, and this one on white, what will be my steering? Negative 100. Total 10 to my what? To my left. I follow you. Are we getting it? So we can see this is enough to do some control. But we always need to scale our control. So we need what? A proportion of this steering. I follow you. So we say this should be multiplied by a ratio or a gain. I follow you. So we say this output times, let me call it steering control. Let me call it steering control. I follow you. So if I multiply this by the ratio, then depending on what value I set that ratio to be, I will have some amount of what? Of regulation. Are we there? Are we there? Yes, sir. Good. So let's build that quickly. Proportional steering with two light sensors. It's as simple as that. So with two light sensors, proportional steering, I will say that I need to know the difference in the two light sensor values, and that becomes my error. So the error is the difference, let me call this error. The error is the difference between the two light sensor values. The beautiful part is that if this sensor is on the white, 100, and this one gets a little of the black by even 99, the error, the difference becomes what? 1. And that one can be used to bring me back on track. I follow. And if I use the ratio of it, it means if I move by 1, I'm going to have, let's say, as you know, I was doing 50%. I'm going to have a correction of what? 0.5 steering. So, we said the light sensor on port 1 the light sensor on port 4 I subtract, right? So light sensor 1 minus light sensor what? 4. That will tell me how much I have drifted either to my right or to my left. Now we say we don't want to use the total steering of the highest possible value we can have is 100 and negative 100. But that is too much steering. So we want to multiply it by a ratio. So we say the result from this should be multiplied by a constant. So let me pick a constant and say that constant is set to 0. Let's say 3. And I'll say let me multiply the result. So if we multiply the result of the difference, which is the error, If we multiply that by 0.3, we are scaling the error down to 30%, which means our steering is always equal to multiply, which means our steering is always equal to 30% of the error, or 30% of our drift is how much we steer. Are we there? So we only pick the move steering block. The move steering block allows you to drive two motors. So let's say I'm driving one at the speed, motor A and motor 1 D. I drive them at the same speed of, let's say, 40. And the steering will come from what? My computation. I put the whole thing in a loop. And then I try. Now, let's see how it behaves. Again, you can see when you're trying to turn to the right, what does it mean? It's turning to the left. And you can see it is turning in, let's say, rotations, I follow it. But you want it to be constantly on. So what do we have here? The motor has to be what? Instead of on for rotations, it should be what? On. I follow it. Are we there? Good. So we turn it on. And the next thing is that when it's supposed to turn to the right, it is turning to what? To the left. So what can we do? We can say that instead of saying light sensor 1 minus light sensor 4, it should be what? Light sensor 4 minus light sensor 1. Or we could also equally say we have swapped the control, so we want to what? Re-switch our controls back to what we had. And then I download. Now the rotations has stopped. So you don't turn it on for rotations if you have a long way to go. Control switch again. Now you can see what is happening. It's unable to take my turns well. I follow it. Why do you think that is happening? Let me run it again for you to see. Maybe anybody who believes the video should know. So before it takes the turn, it is already out of the lane. I follow it. Because I'm only controlling with what? 30% of what? There, which means my steering ratio is too small. I need more control, more turning. I follow you. So what can I do? I can increase the ratio that you put in there, which was 0.3. Let's increase it to 0. Let's increase 0.5 and see what happens. I can equally I can equally decide to say, let me slow down my speed, because you know your turning is also dependent on your speed. At a high speed, you need sharp turns. At a low speed, slow turns will still help you to will take you there. Are you following? So your control is always between your error control and then your speed. Are you following? If I'm driving at a high speed, I need sharper turns. If I'm driving at a low speed, I need what? Slower turns. Or I can use slower turns. Okay. So now we have something a little better than what we had before. But still, we still need some controls. I can still go ahead and increase my turning or my ratio of control. Like I said, this is still not enough control for me. Let me increase from 0.5 to 0.7. And let me try to increase my speed more by saying that with so much control, I can go at a higher speed. Are you following? So let me go at 50 and see the performance. So with systems, what you are looking at is an optimized performance. In this case, we say optimized performance is the highest possible speed which will not take us off track. I follow. You want to speed up the process, but you also don't want to go off track. And that will give you your so you can see it has a higher speed and then higher control. So what you need to do is understand the control variables that you are using. I follow. I can go at a higher speed. All I need to know is for.
So what will happen if you get to a junction where there's
okay.
a black? So like that one.
Yeah. By the formula, a junction is a black and a black, and that is what? 0 minus what? 0. Steering becomes what? 0. We'll just cross as if there was nothing there. 0 minus 0 means steering of what? 0 times the gain is still 0. I follow you. So, 0.
But when we're
so this one will behave. You know, this program is different from what you have just written. So this program would have stopped on there. So if we were writing the program, we could have decided when we use this one, when we switch to this principle. So all what we are doing, we can accumulate all of them into a single program and say, for this section of the challenge, use single light sensor. Now switch to light sensor, go to proportional steering, come to PIE, use that. So you could have a whole lot of principles coming into one program. When you are driving, you don't use one technique. When you get to the runabout, you have to change your style. When you get to a T-junction, you have to change your style. So we can come up with a mix of all of these. Good. Now, that is for proportional steering using 2 light sensors. I'll introduce some few other stuff. So, if you were doing let's try the proportional power and the proportional derivative with 2 light sensors. It's simpler than the 1 light sensor.